Hi guys, let's just wait 5 more minutes. Let's other join. Then we'll just start off with the presentation session. Okay. So by the time you can let me know first, then we can just stack it up like that. Fine.
Ma'am, ma'am,
Yes, yes, yes.
ma'am, when we will get the recorded section, ma'am?
Okay, that haven't been communicated with you, right? Okay,
Uh,
I have to check. I have no idea on that. They will definitely, you can just drop a mail with in that
or else we need to pay some amount to get recorded
HR
section,
department.
ma'am. We
No, no,
need
I
to
don't
pay.
think I don't know. I don't think it like anything like that. So you just need to ask. I have no idea on this part. Okay. So you can definitely ask there. You can just drop a mail there. They will definitely guide you through. Okay.
Yeah, okay, ma'am.
Okay. So who are left with the presentation will be presenting today, right? And after an hour, we will be starting off with today's will be going ahead and doing that we will be starting like we will be doing accordingly, right? After an hour you'll get an hour time to present your presentation, like then we will be starting off with the session. Clear guys? Guys, please tell who wants to present.
Ma'am, can I start?
Okay, may I know your name?
Ma'am,
Vinay,
can I?
right? Okay, okay,
Yes,
Vinay.
ma'am.
Okay, okay, fine. You are ready, right? Your presentation is ready, right?
Yes, ma'am.
Okay, you can just start off.
Okay.
Just share your screen and go ahead. Yeah, your screen is visible.
Okay. Can I start? Hello,
Hello, yeah, tell.
ma'am, can I start?
Yeah, yeah, definitely you can start.
So, hello and good evening, everyone. My name is Vinay Raj Singh, and I'm in final year student of BTech. So, today I'm presenting my mini project titled Olympic Medal Count by Country. So, this is an easy analysis. So, firstly, to begin with, there is a summary for my project. So, the Olympic medal count reflects not only the sporting excellence but also global shift in power participation and investments in sports. The US remains all-time leader, while the Europe, Russia, and China continue as dominant contributors, and more nations are increasingly joining the medal summary. So you guys can read the summary, and next we have the acknowledgement. So I have just downloaded the whole source from the cattle.com, so you guys can check it out from there. And the next we have this inspiration. So it just shows that how the Olympics have evolved over the time. So here, the first cell, I just imported the basic libraries like pandas, matplotlib, and cbon. In the second cell, I just loaded my CSV file, and let me just run. So here is a preview of the loaded CSV. It shows the 5 rows, first 5 rows, and then in the next cell, you can see the information about the CSV file, like the criteria, name, height, etc. And the next cell, here is the data set type that shows the means, method, and maximum minimum. Here just in this cell, I just vote for the number of medals. So this is about 22,69,731. And in the next cell, you can see this is the about the medals won by you, like in which year how many medals are won. So you can see that in 1896 there is 443 medals won, and this continues goes like this. In the next chart, uh, this is a chart about medals won by year. So this is the code for the chart. So here you can see the chart. By looking by the short lines, you can notice the medals that are won by Europe, which is from 1896 to 2016, as per the Kaggle.com. So let me just read some insight about it. So the first one is overall of the trend. The total number of medals awarded has generally increased over the years, showing the growing scale of the Olympics. This is likely due to the addition of new sports, events, and more participating countries. And second one was like early years from 1896 to 1940s. Still, the fewer medals were awarded in the initial years, reflecting the smaller size of the Olympics back then. And from 1950s to 1980s, due to the World War II, there are some trouble occurred for which the Olympics were cancelled. So after the World War II, the number of medals increased steadily, showing the expansion of sports disciplines and greater global participation. A noticeable rise in the 1960s to 1980s reflects the Olympics becoming a major international event. In the modern era, from 1990s to 2016, the medal count stabilizes at a higher level, typically about 2,000 medals for Olympics. This indicates the Olympic reached a mature global scale with many disciplines standardized. So this is about the layer of the key observations. You can just read it. The next, in the next step, you can see this is about removing the duplicates based on any column. So if you want to remove any duplicate from any column, you can just write it here, and this is the output from it. This is about the next cell about missing values and the non-values. You can just have a look at. In the next slide, you can see the top 5 dominating countries. This is a code for that, and the output will be the Sweden has 478 medals, like the most medals, which dominates other. And in the next activity, your voice analysis for top 5 countries. So this is a plot for that. So you can just look at it and
Can you just
see
speak a bit
the
up, please?
that
Am I audible to you?
yes, ma'am.
Can you speak a bit up because some words I am unable to hear some words that you are saying. So try and speak a bit up.
Okay, ma'am.
Okay.
So here in this plot, you can see that purple is for the USA, which have the most medal in this plot, and the sector you have 50. So you can just read about that. Let me do some key observation about it. So the USA dominates. The purple bars are constantly the largest across the most years, showing the USA has been the most dominant medal winner historically. The peaks are especially visible around the 1980s to 2000. European countries like Germany and Great Britain showing the strong performance, particularly from the mid 20th century onwards. Germany shows the fluctuations partly due to the political events like East West Germany before reunification. Then we have the France and Italy. These two countries contribute steadily but generally remain behind the USA and Germany. France shows a constant first present since the beginning, as the Olympics started in 1896 and Paris hosted early on. So the next cell is about the age distribution. So you can guys just have a look at it, and you can notice that the most of the participation uh, from the age group is around from 20 to 30. And in the next cell, we have the high distribution. So this is a about the height distribution. So the most participation from the athletes have the height for about 175 centimeter to 180 centimeters. Then in the next cell we have weight distribution. So this is a plot for the weight distribution. So the most participation weight categories lie between from 6 to 75 kgs. Then distribution chart. So having a brief glance, you can notice the gradual ups and downs. And between 1990s to 2016, there is a zigzag fluctuation. So now some recent key observation about it. The overall growth. There is a clear upward trend in the participation from the early Olympics until recent years. The early years had fewer than 2,000 participation. The participation steadily grows to over 50,000 athletes in modern Olympics. The key next is one is the key growth phases. So from the sharp axis increases are visible around 1950 to 1980s, like into more countries joining the Olympics after the World War II, inclusion of new sports and global events. A major rise is also seen in the 1990s, possibly due to the globalization, professional athletes competing. The next one is tips in the participation. So the noticeable drops during the World War period in the 1960, in 1940 and 1944, the Olympics got cancelled, and around 1980 and 1984, which were affected by the political boycotts. So, like just as said before, the zigzag fluctuations after the 1990s suggest that the dataset may include both summer and winter Olympics and alternating lower and higher participation counts. And the recent era, the participation remains high stabilizing around 10,000 to 12,000 athletes for Summer Olympics. So in the next cell, we have top 10 countries by medals, like the countries that have won the medal the most. So in the first place, we have USA, and then we have France, then we have the Great Britain, and then Italy and Germany, and so on. Now, in the next cell, this is about the sports five dominance, like which sports dominates the most. You can see the all the sports that are dominant. So in the first place, the athletes has been the most dominating sports, and then comes the gymnastics, swimming, shooting, cycling, and fencing, and so on. So the key observations for that project, like we said before, athletics, track and field is far the most participated sport with the highest count exceeding like 35,000 participation. Followed by gymnastic, we have 27,000 participation, and in swimming, we have 23,000 participation. So these three dominate because they include many disciplines and attract athletes from nearly every participating countries. And then we have strong participation sports. Other widely representing sports are like rowing, fencing, cycling, cross country skiing, alpine skiing, and wrestling, all with the crowds above 10,000 participation. This shows a strong representation in both summer, rowing, fencing, and cycling and winter. Okay. Now we have the mid-level sports. Sports like boxing, ice hockey, basketball, and handball and judo have moderate participation ranging around 4,000 to 7,000 participation. Now we have the low participation sport like trampoline, rugby 7, beach volleyball, and taekwondo, which has a lower count of participation. So that's all for my presentation. Thank you.
Okay, Vinay, you could just like stop your screen sharing. So it
Okay.
was good from your end. Good attempt. Okay, next, who wants to go ahead and
Ma'am, can I
present?
present it?
Ma'am, I want to explain
I
my
do.
Okay, okay,
project.
one by one, one by one. Okay. So Rekha, you want to present, right?
Yes, ma'am.
Okay. So Rekha will go now, and after that, who want to go?
Madam,
can I Ma'am,
present?
Okay.
ma'am, can
Okay, okay. Just a minute. Just please, please, one by one. Okay. So after Rekha, who wants to go? Please tell.
Dhanush.
Sorry,
Dhanush.
Dhanush. Okay. Okay, you will go after Rekha. Then
Yes,
after
ma'am.
Dhanush, who want to go?
Madam, I want to
Neha.
present.
Okay. You just raise your hand up. Okay, Sneha. Sneha, you want to present, right?
Yes.
Okay. After Dhanush, you go. Fine.
Okay.
Okay. Okay. Soumya, you want to present? You go after Sneha. Okay. Soumya.
Okay, ma'am.
Okay.
Yes,
Okay.
ma'am.
Fine. Okay. 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 Fine. And Divya, after that, you go. Fine.
Is my screen visible, ma'am?
Ma'am, can I?
Rekha, it is visible. Okay. So let me
Okay.
just stack it up. Then you start out. Fine.
Okay.
Yeah. Yeah. Someone is telling something.
Ma'am, can I present after Divya? Ma'am,
After, yeah, yeah, definitely.
Divya.
After Divya, you can. Let me know your name, please.
Isha Shrivastava, ma'am.
Isha. Okay, Isha. Okay, fine. So after Rekha, Dhanush will go, then Sneha, then Soumya, then Divya, then Isha. Fine. So be prepared accordingly. Okay. Okay. Okay, Rekha, you can go ahead.
Okay. Hello, everyone. Today I am going to present my analysis of cyber attacks trends according different sector using a CSV dataset. So this is my objective. Objective is like to analyze cyber attacks trends across different sectors using CSV dataset, identify the frequency and evolution of attacks over time, determine the most common attack vector and assess the impact on compromised record. The goal is to drive uh, ac- acknowledgeable insight for strengthening and cybersecurity strategies, especially in a high-risk sector like finance and healthcare. So this is my sample CSV data structure, and then here I have import the pandas, MATLAB, Matplotlib, and Seaborn. So here we are load the data set, and then here we have columns like year, sector, attack vector, record, compromise. So we are firstly I start by analyzing the frequency of attack. So by the sector form, here is the like top three sector by number of attacks, like education, government, and transportation. So next is the we are analyzing with the bar chart. So by the bar chart we are analyzing that education, government, and transportation are most affected sector in the cyber security attacks. So next I look at the trends of attack over the year. So this is our we are sorting the like sorting it with columns. So according to year we are sort this and use the sort index here. So highest we have faced in 2027 and 2016, and then here we are using the line plot to see the cyber attack over the time. So here there is a number of 14 attacks in 2016, and the uh, over above the 16 we have in 2022. So next is I analyzing top attack vector. So in the top attack vector we are using the column attack vector to find that like that where we are facing the issue in the cyber attacks. So here we are find the insider thread and ransomware, phishing, SQL injection, man in the middle. So these are the topics we are facing in the like these are the attack vectors. Now with the bar chart we can analyze the attack vector. So with the bar chart we can see that inside thread, ransomware, phishing, SQL injection, these are the top attack vectors in the cyber security like our data set. So we can find with the like bar chart and with the attack vector we can see that here is the insider thread and ransomware are the most top attack vectors. Next is the optional impact and record compromise. So this is the this is our total compromised by sector. So the sectors are government sector, education sector, transportation sector, healthcare, finance, and energy, technology, and retail. These are all the sectors, and our records are this. And to analyze this, we are using the bar chart. This is our bar chart, which is determine the records compromised by sector. So these are the record compromise, like our record, and this is the sectors like education, healthcare, finance, retail, government, technology, transport, and energy. And next uh, I analyze the average record compromise per attack by sector. So this is our compromise attacks per compromise record. So here is the sectors are retail sector, transportation sector, government, finance, healthcare, education, technology, and energy. These are the like record with the by the attacks. And for the uh, to analyze this, I use the like uh, this bar chart. This bar chart, with this we can find that the average record of compromise, like in the retail sector, we will find the most attack sector, by the like we can separate by the attacks. And then transportation, government and finance, healthcare, education and technology, and energy. So these are the attacks per by the sectors. And next is emerging thread and recent year only, like which are the less than 2022, before the 2021. So attacks before 2021. So these are the attacks vectors, like SQL injection, inside thread, password attack, ransomware, malware, man in the middle, DDoS, phishing, zero-day exploit. So these are the attack vectors which are recently used. And then this is the bar chart which are used to like emerging threats since 2021. So these are the attack vectors. And then frequency. So highest frequency is in SQL injection, and then inside thread, and password attack, ransomware. So these are the most attack vectors recently used in attacks. And insight for the cyber attacks trends analysis, in the frequency attacks by vector, we will find that finance and healthcare sector face the highest number of attacks, and the retail and government also experience frequency. Inside the whole education has favor. And then cyber attack over the time, there are clear increasing trends of attacks over from the 2028 to 2023, and the highest number of reported insights have happened in the 2020 to 2023. Top attack vector, like phishing, is the most common attack vector across the industries. Over the frequency vector include malware and ransomware. Advanced threats like zero-day exploit and the SQL injection appear in the later years, showing evolving attacks. And next is the impact on the record, like finance sector is like indicate that compromise is the largest number of record, and healthcare also suffered heavy record. And conclusion for the cyber attacks are increasing. It is increasing year by year, and phishing remains the most common method, highlighting the need of stronger employee training. and finance and healthcare sector are the most targeted, required better security investments. So uh, we need the stronger employee training. So this is my analysis in this topic. Ma'am, I have completed.
Yeah, I have seen that. Great. It was good from your end. Okay. So next is Dhanush, right? You're ready?
Ma'am.
Okay. Okay, you can just present the screen.
Is
Yeah,
it
you can
visible?
start off. Yeah, it is
Yeah.
visible.
Good evening, one and all. Today I'm going to present about a dark web crime dataset analysis. Before deep diving into our project, we just look into a objectives. First, we are going to data preparation and cleaning, which means to clean the raw marketplace data by handling the missing values and ensuring correct data types. Categories and classification. In this market listing into categories like credentials, service leaks, service ID, and other types. Quantitative analysis. It is used to measure and compare the volume of cybercrime listing against traditional narcotics. Vendor analysis, which is used to identify the most prolific vendors on the platform and analyzing their area of specification. Relationship analysis, it is going to give the relation between the key variables such as product and sellers. And finally, we are going to visualize and report it. So initially, we are going to import the necessary libraries like pandas, matplotlib, seaborn, and we are going to load the dataset. After loading, I have used the encoding, which means in our dataset, not only ASCII character, we also contain some special character to maintain it. We are going to use the encoding. In encoding, we are going to use Latin, which means some datasets from a holder system with scrapping and certain European program are often saved using language Latin-based encoding, which means a single byte encoding which maps every byte into a character. That's why. So df.shape, which gives the total number of rows and columns in our datasets. So we are going to see the some preview of our dataset, like vendor categories, which are these are the columns which are present. So we are going to check the column names. Before starting, we are going to clean and removing the white space and standardize the our data sets by dropping some missing values that rows, and we are converting the floating values the price so that the performance on the numericals value will be increased. Here we are going to plot a simple line plot based on the price. So after that we are going to convert the rating to numeric so that correlations we can drop the missing values and all, which converts the string into numeric formats. In this, we are going to show the majority of items regardless of price having very high rating. Is like a common feature of dark web marketplace where vendor's reputation is paramounted. There is no uh, clear correlation between the price and rating. Is a univariant analysis of a vendor. The main objective is to identify the most active vendors on the platform by using a frequency count and bar chart. You can see the vendors like the digit Optimus. Next, it is a bivariant. We are going to plot a price versus rating bivariant analysis. Here, the objective is to determine if there is a relation between the price of the product and seller setting by using a scatter plot. So here we are using the plot to show no clear correlation of trend high priced items to have the rating or low priced items also have the highest rating. We can conclude that price is not a predictor of rating. Customers are willing to pay high price for the items from trusted vendors, but equally low priced items also come from higher rated vendors. So the main goal is our our main goal is to plot our analysis between the credential leaks and service areas. The credential leaks means the sale of batch of data which are sold to some specific online account which have been stolen by using hacking, phishing, or data breaches. Service ADS, it is like a vendor to perform a specific cyber crime task for the buyer so that the buyer is going to pay some vendor time, expertise, or tools. In others, we can see like the sale of tangible item by physical shipping used by stealth packing to avoid the law enforcement. So here we are converting the lower case for the consistency. We are defining some keywords to filter. So the credential leaks password. We are checking the frequency count, like which are the credential leaks, service areas, and others. We have we can see here the roles which have been classified as the credential leaks. We have some vendors, categorized items, item description, basis on price, and we are going to count uh, the credential leaks, service areas, and others. We are going to visualize the frequency of credential leak versus service areas by a bar chart. Now we can see the distribution of categories of top 15 distribution, like it is based on the drugs. This confirms that previous point, the top categories are all drug related, like pills, cocaine, MDMA categories. Data is not visible in top 15, visually reinforce a smaller volume compared to drug trade. You can see the top vendors by listing, like how vendors and their count. And finally, we are going to see the heat map by top vendors versus categories. This appears to be a snippet, which is like a stack bar chart, which shows how top vendors specialize in different product categories. For example, like Optimal and Sexomer are likely dominant in the drugs categories. You can see in the heat map. Thank you, ma'am. That's all.
Okay, fine. Okay, next who is Sneha is there, right? So Sneha, you're
Ma'am, can
ready?
I present?
Yes, ma'am,
See,
I'm ready.
already we have stacked up. Chetan, you can, if there is time today, you can present after Isha. If not, then in tomorrow's session, you can definitely present. Fine.
Sure, ma'am.
Okay, you just, if not today, tomorrow, if we are starting off, you can start off tomorrow and you just remind me, okay?
Okay.
Okay. Yeah. Sneha, you're
Ma'am, is my
presenting,
screen
right? Yeah, it is visible.
okay? So I have made project on phishing detection analysis. It is a project of cybersecurity related field, and like phishing is a cybercrime where the websites are plus where the websites are made duplication, and the features which include that plus one is indicated as the website is the legitimate, and the minus one indicate that the website is a phishing or something like that. So the, this is typically done by the fraud emails, and which are used to store our credit card details or something extra details on the by the attackers. So this project is a machine learning project to detect and classify websites as they are legitimate or phishing. So the there are many features which are included in this project, and this project is taken from Kaggle source. Sorry, the source is taken from the Kaggle source project. So the key features are like URL based features, like, and then if the URL, the number of characters in the URL, like a very long URL indicates that it is a phishing attempt. Then other features are having IP address, shortening service, and etc. The main features are URL based, domain based, and security and content in this website. And the dataset includes 11,000 URLs and is described by 30 unique features. So yes, I have used the three models here, that is random classifier, gradient boosting classifier, and SVC. And the accuracy of all three models are also included, in which the random forest classifier was considered the most highly accurate model. So I have divided the dataset into 80% training and 20% testing method. That testing method, first, it is the steps written that I have done. That is data loading, then at EDA, then model training, then model evaluation and feature importance. So here is the main project. Like first, I have imported the necessary libraries that are required for the project. Then it is loaded by the data set. Then I have dropped the index column, which is not required which is not required. So here is the, so it includes 5,032 columns, and these are all the features which are included. Then by EDA, it is to understand that it is a successful project. It is I have made a correlation map to indicate the features, like a high correlation +1 and -1 indicate that the website is highly correlated, and but there are very less correlations also in this correlation matrix, which indicates that the features are that it are not correlated at all. So it is like the URL length distribution. So a legitimate website it's like URL length, and phishing website URL length. Then this is like SSL final state, which indicates that the legitimate in final state and the phishing website final states. And other towards having subdomain and web traffic distribution. Then the model is trained and comparison is included. So like accuracy of model is there. Yeah, the model precision, recall, F1 score, and all are recorded, and then the confusion matrix is made on the basis of all that. It's like for all three models, random forest, gradient boosting classifier, and SVC, all have trained the model and recorded the confusion matrix. Then the feature importance analysis and selection, that is the top 10 features which are the most important features. It is shown by this chart that the SSL final state is the most important feature, and the less important is the right click. Then I have included an extra point, that the bonus point is that to generate your own features, like to generate my own features, I have included it. And if I want like some of the features, I generate it. Then at last, I have compared the model accuracies, and random forest is classified as the most accurate model, and SVC is classified as the least accurate model in this classifier. So this project successfully demonstrates the power of machine learning combining phishing, and this includes multiple models for real world application. So thank you. That's it for today.
Okay, Sneha. Next, Soumya is there, right? Soumya, you can present. Soumya, you are there. Am I audible?
Yes, ma'am.
Okay, you just present your screen.
Is my screen visible?
Yes, it is.
Good evening. I'm Soumya Singh, and my presentation is on the project Olympic Medal Count by Countries. The primary objective of this project is to load and clean the multiple data sets used related to the Olympic medal, merge the data set into the combined structure format, explore medal distribution across countries and countries by year, and visualize domain in terms of medal count and per capita achievement. The Libraries I've used are NumPy for numerical operations, Pandas for data manipulation, merging, and analysis, and Seaborn and Matplotlib for visualizing. Here I've used three datasets that I've taken from Kaggle. I have first actually uploaded them in my GitHub repositories and then imported it here for better access to the data. And there are three datasets. First is summer.shape, which has more than 14,000 rows and 8 features that include years, sports, discipline, countries, events, and type of medal achieved. And second data set I've used is named as medal, in which there are 162 country data and 5 features such as team combined gold medal earned by that country, combined silver medal, bronze, and combined total medals earned by that country. And the third set I have used is named as dictionary, in which there is country data, country code, and population of the country, specific country. If for data cleaning, actually I have used already the data I've used was already clean, so I didn't perform much of the data cleaning, but I did do some standardization process as eh, the countries were referred to with different names in both the data set, and that is in medal and dictionary. And I've also changed the name of total and standardized the representation of the names. I have also removed duplicate data, which was actually not present. There was not much duplicate values, but it was a necessary step, so I did perform that. And I then merged two data sets, that is medal and dictionary, as two columns from each were required in a further analysis. Uh, Here, I have performed a bar graph analysis for medal distribution in a particular year. Here, I have taken year as 2012. Sorry, just a second. Yeah. Here in the bar plot graph, I have taken the data for the year 2012 uh, and seen how which countries have received the most medals and how it is distributed. This paragraph represents the country which received the highest number of medals in the 2012, that is USA, and all the top 10 countries. Next, I have done medal count by countries. Here, I have counted the total number of medals achieved by each country over the years from 1800 to 2000s. Firstly, I have counted the top 10 countries who have won most medals. This is the data, and this is how I visualize it using a bar plot graph. Here we can see that United States has dominated the Olympics with the most medal counts, that is around 3,000, and some larger countries like Soviet Union, Britain, Great Britain, Germany, and France follows. In this part, I have calculated the medals earned per capita of a country. Mm. For this, I have created a new column called medal per capita, which is the total upon the total medal earned by the country upon the population of that country. So here we can see that although in the all over performance in the Olympics, the larger countries with larger population and GDP were performing well, but when we We see it through the population of this country. The countries with less population size may be dominating here. Smaller nations like Norway, Finland, Sweden are performing on are the top performance. This means that the population size does not guarantee the success. Instead, sports, culture, and specialization may matter the most. In sports size dominance, uh, I have calculated a sports specific insight. Here, I have grouped the countries by sports and like the total medals earned by that specific country in a specific or in all the sports. Like in aquatics, Australia has won in total 193 medals. And for an example, here I have taken top five countries that have won highest number of medal in the sports of wrestling. Here we can see through the pie chart the dominance of various countries in the sports of wrestling itself. Uh, Further on, we are analyzing a country's performance over the year. Here we are taking example of USA, and we are trying to analyze its performance over the years, over various years from the year 1900s to 2000s. We can see in the initial years, the USA has won uh, larger amounts of medals, which remain a little constant during the years of 1920 to 1980. It shows a spike after the year of 1980s, but then it remained constant for a bit constant. Next, I have analyzed the scatter plot of population per capita of a nation. This scatter plot visualization explores the relationship between population and middle efficiency. Uh, Here I've used the scatter plot points to represent the countries, and the x-axis is set to logarithmic scale because the population varies drastically across countries, and the y-axis shows the middle per capita. We can see that in the total medal count, a handful of nations dominates the Olympics, but smaller nations shines when we look at performance related to population. Certain countries specializes in specific sports. That can also be the reason. In conclusion, the analysis shows the dominance of a few nations over the Olympic Games. This reflects that their long-term investment in sports infrastructure, athletics, development, and Olympic participation, and impact of population and resources on the overall performance. With large resources, the absolute medal count, uh, small nations like New Zealand, Finland, and Bahamas excelled when medals are adjusted for population size. This highlights the importance of specialization in specific sports rather than overall size. Sport specific strength we can determine certain sports are dominated by specific nations like Kenya in middle long distance run, Cuba in boxing, Russia in wrestling, USA in swimming and athletics. This reflects cultural, historical, and institutional focus on those events. And we can also see an inequality in medal distribution. A significant concentration of medal goes to a handful of countries, while many nations have never won the Olympic medal. underlining the global imbalance in food investment and access. Thank you so much for letting me present.
Okay, Soumya. So next is Divya. So Divya, you can present up.
Okay, ma'am.
Yeah.
So good evening, ma'am. My screen is visible.
Yes, it is visible. And you don't need to cover all of the details, like all of the point in details. You can definitely just go ahead by the title, then description objective, then directly you can go down to the code and what you have done. You can explain that, right?
Okay, okay.
Yeah.
So my project is about unemployment rate analysis by different regions. So the goal of the analysis is to compare pre and post crisis period and how unemployment rate changes over time. So I have used World Bank style data set, and in my data set have 266 rows and 70 columns. So this is my GitHub link. Next, I have imported necessary libraries and data loading. I have shown first 5 rows. Here we can see that the columns are country name, country code, indicator name, indicator code, and years. Next, I have shown the data type index for the data set. Here we can see that there are multiple missing value in the data set. We can see that from year 1960 to 1990, there is no data. The shape of data. Next, I have shown the count, mean value, standard deviation, etc. for data set. Here we can see that for if we check the maximum value, the maximum value is for year 2024 is 34. For 2023, 35. We can see a clear spike in the maximum value from year 2019. We can see the impact of COVID-19. Next, I have checked for the missing value in the data set, and I have already shown that there are some missing value in the data from 1960 to 1990, and still there are more missing value in the 2021, 2022, and other data. There are 9,575 missing values in the data set. For that, I have removed the data from 1960 to 1990. Then I have checked for the missing value, and we can see that still there are some missing value. Here for country name Aruba, there are missing values. There is no data set for this country. So then I have removed rows, around 31 rows for missing value. These are some countries data which have still some missing value. We can see that for around 5 countries, we don't have data for 2024. For 3 countries, we don't have data for 3 countries, and for only one country, we don't have data for year 2022. We can see that for Ukraine, we don't have data from 2022 to 2024, which may be because of the war condition going on. Next, I have shown the unique countries, then the indicators, and the country code. So for the comparison, I have shown the top 10 countries with the highest unemployment rate. These are top 10 countries with the average unemployment rate of 28.47. And the 10th country is Botswana, 19.53. Here are some possible reasons for the higher unemployment rate: the economic transition issue, limited industrial base, skill mismatch. Next, I have shown top 10 country with the lowest unemployment rates.
Qatar, Bahrain, Kuwait. We can see most the countries with the high minimum and unemployment rate are countries with the resources like oil and gas wealth, again oil fueled economy, the tourism and manufacturing. So mostly countries which are not only based on the jobs, etc. Next, I have shown the plot how the unemployment rate is changing over the years for the top 10 and last 10 countries. Next, I have shown plotted the interactive plot using plotly. So in this plot, we can check for years and for different countries how the values are changing, and we can check the accurate value in particular year. Next, I have plotted for unemployment rate change India. For India, we can see that from year 1991 to year 2018, the unemployment rate is quite stable. And after that, around 2019, the unemployment rate decreased. And in year 2020, due to COVID, it increased again. And after that, the unemployment rate is decreasing. Here are some possible reasons: the economic policy changes, and in 2020, the unemployment rate shot up to around 7.9%. This aligned with the COVID-19 pandemic. And that we can see that there is no effect of 2008 and 9 financial crisis on the rate of unemployment in India. So reason may be that the India's economy was relatively less exposed to the global financial market then. Next, I have shown unemployment rate for few selected countries: China, Germany, UK, Israel, Sri Lanka, Pakistan, Ukraine, US. Next, I have compared for pre-COVID and post-COVID comparisons. I have shown. Here we can see for pre-COVID, I have used 2015 to 2019, and for post-COVID, I have used 2020 to 2024 data set. In this bar plot, I have shown data. We can see there is some clear spikes after the COVID period. And for some countries, the value is quite stable even after the COVID period. Here are some possible reasons. Next, I have shown for financial crisis. So for financial crisis, I have shown the data for three periods: pre-crisis, crisis period, and post-crisis after recovery. So this is plot. So here we can see that the developed countries suffered the most, and the emerging economy like India, China, Sri Lanka were less affected. Next, I have shown income-based distribution. So in this plot, we can see that the high income countries are with the maximum average unemployment rate. So we cannot say that the countries with high income will have less unemployment rate. So we can see some reasons here. So economy like US, UK, and parts of Europe have formal labor market and making job losses more visible in unemployment statistics. In the developing countries show lower unemployment rate. Here I have shown the unemployment rate trends for country income grouping. That's all from my side. Thank you.
Okay, Divya. So today we need to start off with the session. Okay, so it's already 6:35, right? Sorry, 7:35. So we need to start with the session up. So Isha, you're remaining, right? So you can present
ma'am.
in tomorrow's session, right?
Okay, ma'am. Thank you.
Yeah. So first for today, what we will be doing, so we'll just discuss today's agenda. So what we will be doing in today's session. Till last session, we have learned how we can do the pre-processing step by step. So this in this session, we will be trying and building an EDA project from scratch. And based on that, we will try to whatever we have learned till now, we'll try to incorporate up here. Okay, okay, guys.
Yes, ma'am.
Okay. Great. And just wanted to ask, there are some issues, right? There are some people who are saying they are new today. So how many people are there who are new today for this batch? Okay, okay. Okay, okay, got it. So six of you, right? So see, today for this session, it is the second week that is going. Okay, so you don't have to worry. All of the details and the stuff that has already been shared that will be discussed with you, and eventually the recordings of the session will be provided to you. Fine. So you can based on that, you can just check it up for the previous session what has been already done. Fine, so you can check it up accordingly. And based on that, in between also, if you are facing any issue, anything, you can directly ask me. Like after the session, like after the session completes, we do keep a 10 to 15 minutes window on. Okay, so that we can discuss what are the things we can go on and what are the issues you people are facing. So in that session, like in this part, you can definitely let me know if any issues you are facing in the session, in the same thing. Fine? Clear, guys? Who are new, clear? Can you just switch on the mic and let me know?
Yes, ma'am.
Okay, fine. So as discussed, recordings will be provided to you on the same basis, and eventually we will be starting off our today's session. You can start from here. I guess you'll be able to learn because we will be doing hands-on. So I guess you'll be able to understand the stuff. If anything, any query you are having, at the end, we will keep 10 to 15 minutes window open. There we will be definitely going ahead and addressing whatever the issues you are having. Fine? Fine,
Okay,
guys.
ma'am.
Okay, great. Then I'm just starting off with today's session. Okay, just a minute. Let me just uh, present my screen. You people just let me know if it is visible to you or not. Fine? Visible, guys?
No, ma'am, it is not
Not yet,
visible.
ma'am.
Okay,
No, ma'am.
okay,
No,
fine.
ma'am.
Fine, just a minute. I guess today I'm facing some network issue. That's why. Let me just retry. Now, is it visible, guys?
No, ma'am.
No, ma'am.
No, ma'am.
No,
No
ma'am.
one can see. Okay, okay. Just a minute. Now visible, right?
Yes,
Yes,
ma'am.
Yeah,
ma'am, it
ma'am.
is visible.
Yes, ma'am.
Okay, okay,
We
fine,
can
fine.
see.
Okay, great, great. So what we'll be doing today? So today we, as I told, based on our discussion, we will be trying and building an EDA project from scratch, right? So we will be discussing how it is, how we can do it, and we will be taking a data set from Kaggle, right? So and we will be also checking each and every line of code, how we can, what we have done, and how we can do it, everything in details, right? So based on that, so today we will be that this is the thing. We will be downloading this UCI heart disease data. This we will be downloading, and eventually we will be performing the EDA process in details. Along with that, we will be showing how, like, we will be learning how to make this interactive plots. Okay, so today and tomorrow we will be totally focusing on how to create, like how to make a project from scratch. That is a EDA project. Okay, so based on that, this is the data set. If you want, I can just give you the link of the data set. Okay, wait a minute. And the chat. Okay. Fine, guys, got it? The data set?
Okay, ma'am. Okay.
Yeah. So we will be downloading it from here. So we can definitely download it from here. I have already downloaded. So let's see how we will be doing the project, right? So this is the template that we have to follow for any of the EDA based project. And one thing, guys, the thing is, henceforth, if any project is given to you, if it is EDA based, then just go and follow till EDA part. You don't have to go ahead and do the model, like model training and model tuning, that you don't have to do. If it is specifically written that it is EDA, then just go for EDA. Right? Clear? Okay.
Yes,
And
ma'am.
and for the charts, try and use the interactive charts that we will be already discussing. But henceforth, you will be when we'll be giving with any of the project, try and use the interactive charts and try to make it more detailed oriented and colorful, so that it also become easy for people who don't have any access to the data or don't know about on what project you are working also. They can try and get some of the details from the plots that you have gone for. Fine. So we'll just moving ahead with the project app. So this is the UC data. Like, let me just show you how the data looks. Just a moment. Yeah. So this is how the raw data looks. Okay. So this is actually how it is look. We need to perform the EDA analysis on this very data set. Fine. So let me just switch it through. Now it is the template how we will be going through. We will keep the project name. Then this is very much necessary. Project type, what type of project? So this project is basically healthcare domain based project because it is related to heart disease and stuff. So in which domain your project is, that need to be mentioned. Okay, is it e-commerce or related to any other domain, finance, healthcare, that you need to mention after the name of the project, and obviously prepared by who have prepared it, that also need to be mentioned, right? Then project summary in details you have to mention. Here I haven't mentioned, but since this is quite obvious, right? What throughout what you are doing, that you need to be mentioning in the project summary. What exactly is the project thing, like what is the scenario that you have come up with, and actually what is the solution you are getting, and what are the details. Based on that, you have to give the project summary part. Then the GitHub link you need to mention, project statement, right? So sorry, problem statement you need to mention. After this only we will be moving ahead with the coding section. Clear, guys? Clear?
Yes, ma'am.
Okay.
Show that part again.
Which part?
That
This
project
one?
name and all. Yeah, this one. Yeah.
Yeah. If needed, you can just note it down or can take a screenshot of it, right? Done, guys?
Yeah,
Yes,
ma'am.
ma'am. Yes, ma'am.
Okay, fine. So henceforth, when you'll be performing any of the project, you can try and use your own template also, but try to follow this form, like project name, then project summary, like this form should be there, fine? Okay, so first, when we will be going ahead, the very first thing we need to import libraries. All of you know by now, right? So importing libraries is very important. Try and import the libraries here itself, in this section itself, so that you get the stuff in like whatever the libraries you have, like you have gone through, and whatever be the details that you have got, put it in this section itself. If needed later also, like after you have like gone ahead with some part of the code, if any library needed, you can call it there also. Yes, anyone telling anything? Your voice is totally breaking. I'm not getting. Yeah, who is this? We'll keep that window on for 10 to 15 minutes. Then you can just ask whatever be the doubt. As of now, like switch off your mic, right? Mute yourself now. Okay, so that's the thing. So in the import section, like import library section, try and import all of the major libraries, because this is the section from where you can get in through, like in the whole project, which libraries you have imported. Clear, guys? Next, we are going ahead with dataset loading. Okay, so try and use this drive like Google Colab, from Google Colab import drive. In this form, try and import. In the presentation, I have seen someone of you who have used OS. That is good enough. You can do it. But the thing is, when you are trying and putting it, you are like calling each of the folder that is there inside your drive one by one. That is making the process a way more bulky. That is not needed actually. You can definitely call like up to this you have to do, right? You up to this much you have to do. Then just create a path. Okay, there just you like paste off the path where you have just saved the file, like the CSV file, right? So try and do it in this format. Path equals to, and give the path where you have just saved the file. Okay, and then in the like the read CSV format, you are creating the data frame. So df equals to pd.read CSV, and in place of the name of the fold, like the file where you have kept the CSV file, just put path so that it can be tracked easily. Guys, clear? Anyone having doubt here? Everyone clear?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So up to this, try to follow in this method, like because calling OS and accessing the single folder one by one, so that creates like that will make more complex the task, more complex, and also make it more bulky. That is not at all necessary. Right. So next, after you have done a like data frame, you have already created df by df equals to pd.read CSV path, you are creating the data frame. Okay. So after you have created a original data frame, try to copy the data frame. Like that, you can just copy the data set in another variable. Okay. So that it becomes easy. Like in the copied data set, you try and perform all of the necessary work. Okay. So if anytime it is needed, in any of the section of the code, you need to access the raw data, that can be easily done. Got it? Okay, so after this is what how we are going ahead, like we are just reading the CSV file, making a copy of it, so that whenever in middle of the code also, if we need to access the original raw data or raw data frame that we have created, we can easily access that. Fine. So after this, I have just checked it off, like if the data frame that I have created, it is equal, like contains the equal number of features or not. So that I have used it. We can just run it and check it as well. Just a moment. Okay, first for that I have to run the entire thing. Wait a minute. Okay. So for this, see, let me just show you how it occurs when we are putting it in this format. So when we are putting it, so it will try and connect to Google Drive. You have to say yes. You have to do continue and then continue. Right? So it will be bounded easily. Yeah, it is mounted, right? So now we have to read the CSV file. Okay, see, just for a check, I am just showing you people, like to list, we are trying to get all of the feature value that we have got in the raw data set. DF, this is our raw data set, the data frame that we got from the raw data, and now we have just copied the data set for cleaning. Okay, so what are the pre-processing cleaning stuff that we will be doing on the copied data frame. Clear, guys?
Yes, ma'am.
Okay, up to this, everyone is clear? Any doubt, any issues?
And how to finish that path? Where do we get that path?
Fetch that path. Okay, got it. See, for the very first thing from Google.collab import drive, that is the from how this is how you are importing the drive. Then drive mount content.drive, this will be same. This line of code will be same. Okay. So after this, from my drive to this part, this will be all like what is the path that you are getting through. Okay. So just a moment. Let me just show you. Okay, this is my drive. Okay, so this is my drive. I have went to my drive. Heart disease, this is my folder. And here I have stored the whatever be the data set I have stored here. Okay, now you can check the what is the path that you can check. So accordingly, you have to put the path. Clear? So might be there is any other folder in between in your case in after my drive. You have to put that, then that dataset disease, this folder you need to keep, and then the CSV file name. And let me tell you, they are case sensitive. So accordingly put the value, like whatever the details you are putting, try to put it accurately because a Python is case sensitive, you know, right? Clear?
Yes, ma'am. Yes, ma'am.
Okay, okay, fine. So,
Ma'am.
okay.
Ma'am,
So, yeah.
as we are connecting this to our drive and after pushing this file to our GitHub, if others want to run this file, they can't able to access the data set in their drive. So it might be a problem.
Yeah, that might be a problem, but see, like it is more convenient, like when you are putting it in the like if needed, you can just drop like in the GitHub, you can just like upload the data set as well, right? You do have an option like that, but you will be getting the code in this format in the GitHub, right? So that is more convenient because it is also convenient in the sense like calling each of the folder again and again create some issues also in between and also in accessing also, right? So you can try and follow whatever method you want, but in case of OS and getting in through, I just wanted to explain that it is one of the way you can try and follow that. But eventually, when you are performing anything, if any of the project you are working on, if you are finding this not suitable for your project, you want to go ahead and any other processes there that you want to follow and that is working well for you, you can definitely do that. Right?
Yes, thank you.
Okay. So I'm just continuing henceforth, right? Okay, so after this, we need to see how our raw data actually looks, whatever be the details, like we need to understand our data, right? So as we need to understand our data, we have to create it. Like we need to see how our data first look. So for that, we have used read, like clean dot read, like sorry, df dot clean underscore like dot head that actually prints the first 5 rows and rows of the data set that actually we are having. Okay, so let me just show you one more thing. So when we are printing it, like we are just putting it in this format, df underscore clean dot head, we are getting the value in this format. But there are some cases we try to print it, right? Let me just show you what is the difference we are getting then. Yeah, so we are getting it in this printed format that actually we don't need. So we don't print it ever when you are going for just printing, like getting access of the data, like getting access of the access of the first 5 rows or the last 5 rows. If you are using head, try and use it in this format so that you are getting it in this structured form. Eventually, when you are using tail inbuilt function, that prints the last five rows of the data set that we are taking. So try to use it in this format. Okay. Next, data set rows and column. In case of data set rows and column, we try and print what are the data set rows and column we are getting in through. So we have used the df underscore clean dot shape to get the values. What are the number of rows we are getting and number of columns. Next, the data set information. What is the information we are getting from the data set, from the raw data? So what are the columns or the features we are getting? We need to access that. Now the non-null values, count values, and the data types. Okay. Then the duplicate values. First, in the data set, in the raw data set, we need to check if there is any duplicate value or not. So we just use this duplicated to get the duplicate value, and I use the sum function to just count it down how many duplicate values we are getting. So based on that, we got that there are no duplicate values in this data set that we are actually getting. So duplicate means there are values that are identical. Okay, so that kind of like row wise or column wise equally like values for both the rows or both the columns. This type of data we haven't got. So we have, it has printed 0. Now we need to handle the missing values or null values. So similar way, we have used is null function, inbuilt function that like showcases is the like what is there any null values or what is the null value, so that it counts actually. And sum function actually adds the values up for each of the column. Okay, so it is column specific. So you can definitely see here in case of id we are not getting any missing value. From id to cp, this is the name of the features or the columns that we have got. So we are getting 0 missing values. But from here till going down to thal, that is this thalassemia, these values are coming up in this format. Like we are getting this many missing values up there. Okay, so we need to handle that, but all time getting it into data, it's difficult to understand. So we need to visualize. When we are visualizing the stuff, it becomes easier for us to understand, like where, in which data, in which feature we are getting most number of missing data or missing values basically. Got it? So here I am using Missingo matrix. So this white line specifically let us understand that these are the missing values in this data. So you can see ID, age, data set, CP, all this in all of this in all of these columns, we are not getting any of the missing values. So all of the values are there in this values. From here going down to thal, we are getting the values that are missing. Okay, this white stripes of the line signifies the missing values. Okay, so make it more clear, I have used heat map. Whatever suits you, you can use that based on your like preference and understanding. Okay, so here also it also gives the same kind of value, so I can just compare and also let things know that both the graphs are showing similar kind of data. So my data is kind of accurate in terms of visualization purpose. Clear up to this? Clear, guys?
Yes,
Yes,
ma'am.
ma'am.
Everyone
Yes, ma'am.
Yes,
clear?
ma'am. Yes, ma'am. Yes, ma'am.
Okay, fine, great. So now we'll move ahead. We need to know the data set that we are using. What we did as of now, we have gone ahead, we have seen the CSV file, seen the raw data, we have seen how many missing values are there, is there any null values we are getting, or is there any identical values we are getting, and we have just printed, we have just checked and get a look how our data set actually looks. This much of the like whole program, this much is done. Now we need to know our data set, how our data set actually is, what like here how our data set means, what are the intricate details that we are getting in the data, what are the features we are working on, this we are seeing in through. Clear? So based on that, we are going ahead. We are just trying and printing the column names and the data types of the columns. Okay. So here we have printed the column names. So you can see here. So let me just go to next line so that it is easier for you to understand. Yes. So in the index, we are getting the value as ID, age, sex, data set, CP. This all the features, the under like the column names. These are the column names that we are getting. Okay, and then we have checked off about the data types of the columns. So for in ID, we are getting integer type value, age, we are getting integer type value. For the gender, we are getting the object type value. For data set, we are getting the object type value. So this you can see how for against what column, what type of data values we have got. Clear, guys?
Yes, ma'am.
Yes, ma'am.
Okay. So are you people taking into note or anything about what step to follow when and how we are performing? Because on the similar data, you can do like in the similar data, I have given you the data set, like the link of the data set from Kaggle. So you can practice on your base, like your free time also, you can try and practice and get the thing solved, right? So next we have gone ahead with dataset description. So how the dataset description is all about, like what it actually showcases. So it generally works according to the integer value or float value columns. Okay, so here you can see for ID we are getting integer value, for age we are getting integer value, for cholesterol we are getting, trash BPs we are getting, T-rest BPs, we are getting also float value. So we are considering those columns only. Fine. For getting the description of the data, because description of the data contains the count value, the mean actually this is the average value. Then the standard deviation value. What is the standard deviation that we are checking in through? Okay, then we are going ahead with mean. This is minimum value. What is the minimum value we are getting in the entire column values? Okay, then 25%, 50%, 75%. That is the quartiles. Quartile 1, quartile 2, quartile 3. Okay, that contains the 25% of the data, 50% of the data, and 75% of the data, and the max value. That is the maximum value. Okay, so that is definitely numeric or float value specific, right? So we are only considering the values whose data types are int or float. Clear? Understood?
Yes.
Yes, ma'am.
Okay, great. Then variable description we are checking on. So what are the variables we are looking into? What are the columns? And is there what are the unique values we are getting across the columns? Okay, so ID, we have previously checked already, like there are 920 rows we are having. So all the rows are unique for ID. So age, we are getting 50 different values. For the gender part, we are getting 2 different values. Data set, we are getting 4 different values. So on, we are going. So we are actually checking the unique values we are getting per column or per feature we are taking into consideration. Great. So now the major part that we are looking into, that is data wrangling or the data pre-processing part. So after this data pre-processing part, we will get into the EDA part, like the visualization part. Like there we will be showcasing the interactive charts, how we are making the plots, how in what format the columns or the variables are linked with each other. We will be able to access the correlation. Okay, so after data wrangling, we will be going into the EDA part. So let's discuss this part in details. So we'll consider each and every section of the code and try to understand what it says and what we did in this section of the code. Fine. So in the data wrangling, very first thing is to extract and remove the duplicates. Okay, so this is the very first thing. So previously we have checked, right? So is there any duplicate value for this data set or not? So we know that we don't have any duplicate values, right? So we need to write the code in such a way that it will check if there is any duplicate value or not, and will print the shape, like what is the structure of the file, will print it accordingly. So exactly what it does. So this part, that is print checking for the duplicate value, this actually what it does, it just print this value in the output. You can easily see checking for the duplicate value. So what step we are performing, we are trying to let the like the person who is seeing the code, I am trying to let the person know that what I am doing in this step, I am checking for duplicate values. You can definitely use the comment section or the comment form, you can definitely use, but I try to make it in this format. It's up to your wish how you will be presenting. Presentation is totally upon you. Right? So /n, that signifies next line. Okay. So next line, I want to put a gap. Here you can see there is a gap in between, right? So /n, I put it to put a gap in between. Okay. So then I have printed the duplicate values, that is df underscore clean duplicate sum. So what I actually is doing, df underscore clean, this is our data set, the copy data set that we have got. That is the table of the data, right? And dot duplicated, this actually what it does, it actually checks every rows, whatever be the rows in our data set, it checks each and every row and marks true value if the row is exactly same as the previous value. Right? There should be any consideration, right? How I am checking it through. So like in this section, you can see, so it will check each and every rows that you are getting. Suppose for 45, this row I am getting exactly same with this. So it will return a true value. Got it? So this is how it is. So based on that, if the value is not same, this will return a false value. So I need to count the values. For that, I am using this sum. How many values I am getting as true, that I need to sum it up, right? So that I need to get the values that this number of values are duplicate. So I am using this form. Okay, then we are going ahead and just doing the cleaning operation. Like we have just put it the values like this and just printed the shape after removing the duplicates. What is the shape? I just wanted to see it, so I have seen it. And the duplicate values, I have got 0 up here. Okay, clear? This much clear, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So how it is iterating over the data set, that is clear to you? Or should I give you a example, like a small example to understand? Is it clear?
Yes, ma'am.
Everyone clear? I don't have to put any example, right?
Clear, ma'am.
Okay, great, great. So then I'm moving on, right? So next, what is the step? We are going ahead and checking if there is any inconsistent value that we are getting through, and how it is that we are basically checking up here. Okay, so inconsistent means is there any value whose name is different? How, or is there any spelling error or not? That we need to check. So for this only we have initialized the previous sections and how we have got through. Now here we have taken into consideration that this for this column, that is thal, we are getting the value that is different. We are getting reversible. We are getting two values, that is reversible defect and we are getting reversible defect. Right, but this value like reversible defect, this data we are getting in the column. Let me check. Okay, yes. Yeah, you can see here, right? So we are getting the value reversible defect. But then you can easily understand, right? The spelling is not correct. So it should be reversible, reversible defect, right? So we need to clarify that. We need to check it through and we need to we need to solve this problem up. For this, we are fixing the inconsistent entries that we are getting in through. Right. So for this, I as usual for the previous section, what I did, I have printed what operation we are doing. So here also I have printed what operation we are doing. We are fixing inconsistent entries that we have printed off. Now we need to check, correct the spelling issues that we are getting across that very column, thal column we are getting, that we need to check it off. So we need to replace, we have used the replace inbuilt function. There we have used this value. This is the original value that we are getting in the data set. This is the like the value that we are getting, this value we are getting. This is the mistaken value that we have got in the data. So we have to first put it through like this and we have to replace it with the actual correct value that we have put it in. Okay, so after that, after running the code, we are getting like we are doing this operation and this thing has been resolved. Okay, now the next step is handling the missing data. Missing data needs to be handled well before we are starting off with any of the operations, be it EDA analysis, or we don't want to move ahead with EDA. We want to directly go ahead and build a model, train a model, and evaluate the matrices of the models. So then also this handling this missing values is very much necessary. Okay, so similarly, what we are doing as we are doing for the other section, we are printing what operation we are performing, that we are printing off. Next, we have got multiple, like I guess 20 number of rows we have got on, right, for this data set. So we have got multiple type of data, like what is the data types? Data types wise we can differentiate. So we have got numerical columns and categorical columns, right? So we need to check in through how we can solve this. So num dot column, this actually is a list of column that contains numbers. Okay, number values or numerical values we are getting, that actually stores, this is the list of these values that we are getting. So now we are doing a for loop where we are considering each column at one and eventually iterating over each of the row against the column. And if we are finding any of the missing column against those missing row actually, or missing cell, we can say, against that column, we are filling that column with median value. Okay, so fill NA, this actually this one fill NA. This this is an inbuilt function that what it does, it fills missing value, like the whatever the empty cells I am getting, there we are filling those empty cells are getting filled with the median value. Median, that is the middle value, or we can say it is the say it accordingly, the average value we can say. Fine. So you might be having a question, why median value? What is the reason we are putting the median value? So median value we are only considering in case of numerical data or float data that we are getting. Right. So their median is usually used because that is number specific and it doesn't affect the extreme value. Extreme value, like there are certain values that we are getting, the outliers. Okay, so that doesn't get affected in the eventual process. So we are using the median value. Okay. Clear up to this? Clear why we are using the median value for numerical column?
Why can't we use mean?
Sorry.
Why can't we use mean of the values? Average of
See,
the values?
I got it. So here median, we are basically using median, actually basically finding the middle value. Middle value are more accurate values we are getting. See, there are certain datas that we are, if like suppose it is a numerical data, okay, so numbers are there, okay, so if we are trying to put in the mean value in that form, so it will turn into, there are situations, right, where in the mean value we are getting the float value, right? So if we are getting only the positive integers value, suppose in case of age only, we are getting the value in that format, and we are trying to put the mean value there, what we will be getting it there, what we will be actually getting in true, we will be getting a float value up there. So that is not acceptable in this sense. So for any of the numerical columns, we generally try and fill with the median value that we are actually getting. Clear?
Yes,
Actually,
ma'am.
median is useful in case of any of the numbers because it doesn't affect the extreme values, like the outliers, that doesn't affect those. Mean value doesn't, like in certain cases, there is certain usefulness of the outliers also based on the performance of the data that we are checking on. So outliers keep it intact, whatever be the outliers, so that it is easily detected. The outliers can be easily detected, and we can detect and treat the outliers in the very next step. Fine. So for that, we are keeping it as it is, just replacing the value with the median value in case of numerical columns. Clear?
Yes, ma'am. Got it. Thank you.
Okay, fine. Okay. So next, what we are doing for categorical columns, categorical columns, you people understand, right? What categorical columns are. We are getting true, false, this kind of value, or yes, no, normal, abnormal. Like there is a switch between two values, male, female. This kind of values are considered into categorical columns. There we need to replace it with mode value. Mode, actually, what is the most frequent value we are getting? That is actually the mode value. Got it? Clear? Guys, understood?
Yes, ma'am.
Everyone, right? Clear why we are using the mode value?
Yes, ma'am.
Ma'am, more
Yes.
of zero place. Can you
Zero?
explain that?
I didn't get you.
Index
Can you?
position.
Sorry, I just missed out. Can you come again?
There is an index position mentioned in the mode
Okay,
function. Why
zero.
is that?
Zero, this one, right?
Yeah, ma'am.
See, 0 is taken for the first value, for the very first value that we are considering. Suppose male, female, male, female, male, female. This kind of, this is the actual categorical value we are getting in case of gender. Okay, so 0, it actually takes the first value in case there are multiple of modes are there. Right, if there are multiple modes are there, we are just we are taking the first or the initial first value. That's why 0 has been put it into consideration. Okay.
Okay, ma'am.
Yeah. So this is how we handle the missing values. Now we need to detect and treat the outliers. How the outliers we have to take into consideration. So we need to take it off because we have seen after performing all of this, like numerical column we have changed into median, then categorical we have changed into mode. After this, when we have printed, we have seen that missing values left is 0. There is no such missing value to handle. So all of the missing values has been already been handled, right? So now we need to check for the outliers and detect the outliers, right? So for this, we need to check into consideration. So as here we are using that interquartile range, we have in the last class only, we have learned how we are taking into consideration the interquartile range. So here we are performing the interquartile range here to like treat and detect the outliers specifically. Okay, so first we are printing what what performance we are doing, that we are printing up here. So here we are basically, the first step is printing the message that we are getting in through. Next, we need to do the way here, if we consider into stepwise, the very next stage is to select the numerical column. Whatever be the numerical columns we are getting, we are just selecting those. So select D type np.number and converting it into list, that actually take into consideration all the numerical values, that like numerical columns that are there in the data set, and taking into a list format. Okay, Python list format. Okay, so next, after this, what we are doing, we are running a loop with numerical column. With this numerical column that we are getting, we have given the name as numerical column. This is actually a list that contains the features or the column names that contains the numerical data types. Okay. So in the loop, actually, we are running a loop. So loop will work through all of the numerical columns one by one. Okay. So here now Q1 we are doing, and Q3 we are doing basically. So we need to get in through for the interquartile range. So 50% we are taking into consideration. So Q1 consider the data that is below like 25% of range, and Q3 contains a 0.75 in this range. Okay. So Q1 is creating the lower boundary and Q1 is the upper boundary that has been created. So we need to get the value in the Q. For getting the IQR, that is interquartile range, we need to subtract these values. Q3 minus Q1 we need to do. Okay, so for measuring the middle value, middle 50% of the 50% spread of the data that we need to calculate, so we are doing into interquartile range. Okay, so now we are creating the lower boundary and the upper boundary. So since it is lower boundary, we are taking into consideration Q1 minus 1.5 into IQR we are doing. That is interquartile range that we are getting, that we will be doing. Okay, so suppose, let me just give you an example so that it becomes easy for you to understand. Okay, so suppose we are getting Q1 equals to 100. Q2 we are, Q3 we are getting, because we are only considering Q1 and Q3. Q3 we are getting, suppose 200. Then what would be IQR? IQR equals to Q1 minus Q3. Q3 minus Q1. Q3 minus Q1. Right. So here we will be getting 200 minus 100, that is 100. This is the IQR, interquartile range. Okay. Now what we need to do, we need to set the lower boundary and the upper boundary. Lower boundary, what we are doing, we are taking Q1, Q1 minus 1.5 we are doing, and multiplying 1.5 into QR, like the interquartile range, IQR. This is actually the form. So here, if we can check, so lower we are getting 100 Q1, because the value is 100, minus 1.5 into 100 we are doing, right? So 1.5 into 100 we are getting in through, and that we are multiplying it with that. So why we are getting 150, 100 minus 150. 100 minus 150 we are getting. So we are getting value minus 50. Clear? Clear, guys?
Yes, ma'am.
So upper section, what we are doing? Simply we are taking Q3. So Q3 we are doing. Then we are just adding up 1.5 into the interquartile range. So what we are doing, Q3 here, what it is? 200, right? So 200 plus 1.5 into 100. So eventually 200 plus 150, we are getting 350. Clear, everyone? How we are doing the lower and upper boundary, clear?
Yes.
Okay.
Yes, ma'am.
Everyone clear, right? Okay, so if everyone is clear, then after this, after we are how you are creating this upper like lower and upper value we are doing, then we are replacing the outliers with the median value. Whatever be the outliers, we are replacing it in with the median value, because in the previous section we have already handled the value like the missing value with the median for the numerical values. So here all of the values are numerical. So we need to handle this, and whatever be the range, we are just filling it up with the median value. So this is how we are doing it. And in this section, if what we are doing here, if the value is lower, we are putting it into median value. If the value is smaller than the lower limit that we are getting, we are replacing with the median value. And if we are getting the value that is how upper than the limit, like if the value is like for according to the example, if the value is like lower than minus 50, we are replacing the value with the median value. If the value is above 350, we are then also replacing it with the median value. Fine. Then what we are doing? We are doing the next operation that we are doing, that is encoding. Sorry, we are doing the scaling, then we will be doing encoding. So scaling, basically what we are doing, so in this section, first we have just print the message, like as for usual thing we have done this. The second, we need to select the column to scale, like for which column we are needing to scale. So similarly, we are doing this. So we are getting into ID and num. In this two columns, we need to check in through. So skipping certain, like we want to skip this column for like, see, we need to do the column, but we don't need to do for ID and num. So we are just not in. We are putting if column not in this. We are only considering the other columns, but not this. So we are not considering this. Okay. And then for the columns that we are getting, the resultant column. So scale dot columns only called only what actually it considers, it contains only the numerical features that need to be scaled. So based on the numerical features, we can think of the age value, we can scale that value, cholesterol level that we have seen previously, we can definitely scale them because we have seen that apart, right? So we need to scale them. Okay, so in this section, scalar, min max scalar, what we are doing, we are using the sklearn tool in mean max scalar value we are using. So we are trying to put it in the range. We are want to scale the value. We don't want to like after outliers has been mentioned, we need to just scale the value. That's why we are performing the scaling operation, because we have if we get any scaled value across the columns or features, then our machine learning model performs well because the range kind of kept same. Suppose in case of age, we will be only considering the scale with the from 0 to 100, right? So we won't considering the outliers, that is if anyone having age around 250 or 300, that is not realistic, right? So we will be scaling the age in between 0 to 100, or we do have a cholesterol level, so we can just scale it around 100 to 300 to make the model give more impactful result, right? So this is how we are doing the scaling and normalization part. Next, we are moving ahead and doing the encoding. Encoding is basically done in the categorical features. Whatever be the categorical features that we are getting or the categorical data we are getting. So there only we are doing the encoding part. So encoding basically what encoding does, it understands the categorical features. Whatever be the categorical features, it understands that and try and convert it into numbers. Okay, so machine don't understand, right? If it is yes or no kind of value or male or female kind of value, this the machine doesn't doesn't understand. So machines are always good with numbers. So we were converting it with the numbers. Uh, Actually, we are generally yes, no. If this kind of value are there, so we are changing it with the 0 and 1. This kind of value. So these are these are separable also, and the machine is able to understand also. Got it, guys? Clear? Guys.
Yes, ma'am.
Yes, ma'am.
Okay, fine. Up to this, everything
Yes,
is
ma'am.
clear, right? Up to this,
Yes,
everything
ma'am.
is clear, right? Okay, fine.
Yes, ma'am.
Yes,
So
ma'am.
very next step that we will be doing is the feature engineering. We will be doing feature engineering. So first what we are doing, like we are creating a binary target column we are basically creating. So here what we are doing. So we are using like heart disease. This set we are basically considering. So this num column we are getting num. Clear? Seen? Right? So this is the original column that we have got on. That indicates that basically indicates what is the heart disease, what is the severity of the heart disease basically. So it will consider 0 or less greater than 0. This kind of value it is generally identifying. So we just need to get in through and create a binary target volume whose name is heart disease. There we will be considering or taking into consideration if the null value is 0. We have pass this comment that if null value is greater than 0, it will return true value. And if the num value is equal to 0, it will return the 0 value. Okay. So, and as type int, this actually what it does, it converts the true or false value into 0 and 1. That is, if the value we are getting in heart disease column 0, so we are getting like 0 means no heart disease. The person is totally fine. If we are getting 1, then the person is having a heart disease. So this is how we are creating a binary target column that was not actually there. We are creating it so that it makes our model easier to understand and learn also. Okay, so next we are doing age group. So in age group, what we are doing, what is the purpose actually? We want to convert the numeric value into the categorical value that will tell us like young value or middle age value or senior, how the members are in this range. So we have created in that format. Okay, so for this, since we have taken in beans, we are getting 40, 55, 100. These are the extreme levels where we are taking into consideration. So this actually what beans equals to 0, 40, 55, 100, what it actually defines. If the category is 0 to 45, we will consider it into young. If 41 to 55, we will consider into middle age. If 56 to 100, we will consider into senior. Okay, so in this form, we want to label it down. Okay, so now next we need to convert the age group into numbers. Okay, so after it is been done, we need to convert the age group into numbers. So for that, we have created this dummies that actually converts young into text or 0 to 1 or in middle one, 0 or else. In this format, it is actually creating for our better understanding. Okay. And next, we have gone ahead and created cholesterol per age ratio. What actually is the purpose? We create a new feature or new column whose name is cholesterol per age. That shows what actually it shows. It shows the cholesterol relative to age. based on the cholesterol, how relative it is. So it has actually created it like that. So after that, after it is being created, we get the new features are added. So all three columns of the features that we have tried to group in, so this have actually created. Okay, so now after we have performed all of this, so we have seen in through that id and num column, we have already created another column we using this num, right? And id, this is not actually, we are not requiring this in any of the case, we are not requiring it, be it eda or any of the model training and building, right? So we are just dropping off this unnecessary columns. So we have just dropped off this column, and just final how the actual data set now looks, we have just printed it. Okay. And also we have also considered the target value. We in every of the data set we need to put in a target column, which actually makes the major changes or major necessary difference is made with that very column. So heart disease that we have recently created using the bulk value, using the binary value, and num column, previously created num column, we have used that and created a new value, that is heart disease. This new feature has already been created. So we need to check what is the number, if the classes are equal or not, if these values are like, suppose if for 1 we are getting 500 and for 0 we are getting only 10 or 20 values, then there is a class difference, right? Then we need to this handle this imbalance class. Got it, guys? Clear?
Yes, ma'am.
Yes, ma'am.
Okay, great, great.
Yes,
So,
ma'am.
till today we will be doing this pre-processing. Tomorrow we will be learning or showing how we can create this beautiful interactive charts. Okay,
Okay,
understood,
ma'am.
guys?
Okay, ma'am. Okay, ma'am.
Okay, okay, great.
Okay, ma'am.
So till now everything is clear, right, guys?
Yes, ma'am.
Yes,
Yes,
ma'am.
Okay, okay, correct. Okay, great. So, some of the people were saying some issues, right? So we have just kept a 5 to 10 minutes of window on. So anything you want to ask, you can definitely ask.
Excuse me, ma'am.
Yes.
Can you please repeat what is the function of min-max scalar? I missed it actually.
Okay, I already told you, right? Okay, just a minute. Just a minute. Let me just share the screen again. Is it visible?
No, ma'am.
Screen is visible? Okay, I'm just letting you know. You just listen to me. I guess you'll be able to understand because facing some network issue. Okay, Frida. So
Yes,
mean
ma'am,
max.
that's fine.
Okay, so mean max scalar, that is actually a tool that is sklearn. Basically, we are using it that used to rescale the number. We whatever be the number we are getting. Suppose age also, like in any of the cases, we do get the numbers. In case of suppose age, cholesterol, in those section we do get the numbers, right? But in certain there is a requirement we need to just range it between a values, right? So like this actually ranges the value in between 0 to 1. Okay, so this actually scaling is mainly done because we know about machine learning models, right? So machine learning models work better when we are having this range up. When there is certain range we are getting, in that range machine learning models work very well. Okay, so let me just give you an example that I have given. Like, suppose there is a person. Like in case of age column, we are getting the age in between 0 to 100 and cholesterol in between 300 to 300, right? So that is the way it has been scaled. This the model is be giving more importance to the to the range from 0 to 100 in this age group people, because it will omit the outliers, right? So we might get the values in the range like 200, maybe the data of one person, maybe, right? Because there are many data that we take into consideration. So those data are outliers, right? So we need to remove that and work on the real-time data that actually affects. So based on that, we are using this mean max scaling. Clear? So for use the formula that I might have told or I might have missed out. Just in case I missed out, I am telling. So x scale equals to x minus x mean by x max minus x mean. That actually converts the value to in the range of 0 to 1. So that makes the performance and understanding to the model easier in this range. Okay, clear, Fida?
Yes, ma'am. Thank you.
Okay, fine. So guys, any question? New people who have joined, if you have any, see, new people, are you there in the meeting or already left?
Yes,
If
ma'am, I'm there, ma'am.
okay, fine, got it. See, the thing is, since the class has already started, the recordings will be accordingly provided to you. So today you attended the class. Did you understood what we have gone ahead with? Anything you understood?
Yes, ma'am. Yes, ma'am. I have understood, ma'am.
Yes, ma'am.
Okay,
It's clear.
okay,
Yes,
okay,
ma'am.
okay. Great. So you are new people, right? New people who have joined today's session, right? Hashini, right?
Yes, ma'am. Yes, ma'am. Hasini, ma'am.
Okay, Hasini. Got it, fine. So today you understood, right? So eventually you will be provided with the recorded lectures. Okay. So you just go through the lectures. If any issues, anything you are facing, we will be addressing those. Don't worry. Fine.
Okay, ma'am. Thank you, ma'am.
Okay, fine. Uh, Sajruddin, you want to say anything? You can switch on your mic and tell. Nothing? Okay, fine. Great. Yeah. Yeah, tell.
Ma'am, on which platform we will get the recording?
That will be definitely communicated to you, okay, in the ad from the admin section itself, and who have given you the links and details about those person will be definitely connecting with you and letting you know about the recording part. Fine. Because
Okay,
I
ma'am.
actually don't have the exact knowledge how the recordings will be provided to you. Okay, so they are the best person whom you can consult about this.
Okay, ma'am.
Okay,
Thank you.
okay, fine. So we are just wrapping up today's session here. So tomorrow we
Ma'am,
will
what
be
is the
seeing.
project we need to do in this week?
Sorry, I didn't get you.
What is the project we need to do in this week?
That will be definitely letting you know by tomorrow. Tomorrow after class, the project details and what project you have to work on, that will be shared to you. Fine. Okay, fine. Okay, great then. Bye,
Ma'am,
guys. Yeah, Shrija, tell.
ma'am, ma'am, actually, I haven't given presentation, so shall I give it tomorrow?
Yeah, definitely. Not an issue. Two, three people are already enlisted themselves. Tomorrow, you definitely can showcase. Fine.
Okay, okay. Thank you.
Okay, fine, Shrija. Fine. Then we are just wrapping up. Yeah,
I want to ask those who have not submitted their week one project, is
that
there
is
any extension?
extension. This extension has been given, right? The deadline was on Monday, right?
Okay.
So if so this much time people have already taken, like, actually the presentation is taking time. The rule is you need to submit the project on the deadline only. Fine. So deadline is on Monday, so you have to submit it on Monday.
Okay.
And the presentation can take time because see, in each of the batch we are getting like 50 today, 50 people have joined, right? So for the presentation session, 50 people, since 50 people have joined at one go, we can't take the presentation. And this presentation should be recorded because this will get into evaluation, right? In the further evaluation. So that's why it is been mentioned in this format that presentation will go every day before class, and after that the class will be there, but on the deadline itself you need to submit the project, right?
Okay. Like we have to submit the project on the deadline, but the presentation is we can present anytime, right?
Your voice totally got broke, I cannot get you.
Ma'am, I mean to say, like we
Yes.
have to submit our project on time, but the presentation is still ongoing, like on daily basis, right?
Yes, exactly. Because as you understand, right, on a single day, everyone's presentation can't be taken, right? So that
Yeah.
is the reason. So you have to submit the presentation or like, sorry, the project on dead, like whatever the deadline been given to you. Actually, for every week, it is on Monday. By Monday, you have to submit it. Right? Clear?
Okay. Okay, ma'am.
Okay.
Thank you, ma'am.
Okay, fine. Okay, guys, any more questions? If not, I'm just wrapping up today's session here. We'll meet tomorrow again. Okay. And based on that, we will be discussing and learning together. Right? Bye, guys. Then.
Bye,
Bye, ma'am.
ma'am.
Bye.